Hey guys, this is Mr. Cozy, obviously. I just finished grading Homework 8, and I noticed that there were some misunderstandings about what a confidence interval is telling you, and this is important because the Bear Height case study and Homework 9, they both rely on you having a really good understanding of how to interpret a confidence interval. So I threw together this video really quick, just to kind of run you through a couple of scenarios and make sure that you're clear as to what an interval is and is not telling you, so that there's no confusion on the Bear Height case study. So it is currently 11:20. It is late at night, and I want to get this done quick. So let's get started. Okay, let's start looking at question one. Question one. When you're all done, you get an interval that estimates the mean hours worked per week by all college students. And I don't remember precisely what that answer is. It doesn't matter. Let's say it's 12 to 14, and it's not, but let's just say that it is. Then any number in this range from 12 to 14 is a reasonable value for the mean. And you can pick any number in this range and say that it is reasonable to say that the population mean is whatever that number is, and as long as it's in this interval, you have yourself a true sentence. Okay. Now the thing about question 2 off of the homework is we have someone claiming that the mean is actually 10. 10 is not in the interval, so it is not a reasonable value, and it is not reasonable to say that the mean is 10. Okay? Now, the reason why I'm focusing on these two statements is we can switch around the nots in each of these statements and still have true statements. They're not equivalent because they say something different, but that they are true statements. And this becomes relevant in the next question. But let me tackle this one right here. I can move the not around and take this statement a little farther. I could say that it is, oops, let me get rid of this. Okay. That it is reasonable to say that the mean is not 10. Because if the mean could be 10, the interval would include it. So both you get both of these sentiments out of the fact that 10 is not in the interval. Whichever one you want to use is depends on what you're trying to do. In question 1, it's this. Okay. In the next interval question where you have the standardized test, the issue at hand is whether or not this is the case. because you can't say that the mean isn't something unless that something is outside of your confidence interval for the mean of the population. Okay, so let's take a look at number two, at that second question, which I think is number 4. It says that there's a sample of people with learning disabilities. You have a mean and a standard deviation, and you want to calculate a 99% confidence interval for the mean score for people with learning disabilities on this test. Once again, I don't remember what the answer is, but let's say it's 92 to 107. Okay, and it's not that, but any number in this interval is a reasonable value for the population mean, and it's at this moment it's important to remember what the population is. In this case, the population is people with learning disabilities. We took a sample, we got an interval. That interval uses our sample mean to estimate the mean of the whole population of people with learning disabilities. And I know that it sounds insane for a sample of 49 people, and I'll be honest, there's maybe some subgroups of the larger population that you're missing with a sample that's so small. But throwing that aside and trusting that this is a simple random sample, or even if it's not a good sample, that's beside the point. We can still calculate a confidence interval with that sample, and if it's a 99% if it's a 99% confidence interval, 99% of all possible samples, good and bad, will still give you an interval that contains the mean. Okay, so anyway, we have this interval, and the question is, the mean for everybody, for the whole population of human beings, is 100. Is it reasonable to say that the mean for people with learning disabilities is any different? Is it reasonable to say that the mean is for people with learning disabilities is not 100? Okay, so let's note that 100 is in this interval. Therefore, it is reasonable to say that the mean, the population mean for people with learning disabilities is 100. Okay, and I get that out of the fact that 100 is in my interval. Now that's not quite the question. The question is it reasonable to say that the mean isn't 100? And we can throw in a couple of knots, make this a double negative. It is not reasonable to say that the mean is not 100. Okay, it's a different sentiment, but one that and it's one that more closely answers the question at hand. Using these results, I can't say that the mean for people with learning disabilities is different from 100, because 100 is in my interval. Okay, and that's where this comes from. Now, just a side note, some students got confused because there's a lot of other numbers in this interval: 101, 95, 105, all of these are in this interval. Aren't those also possible values for the mean? And the answer is yes. They are all reasonable values for the mean, and they are equally reasonable as 100. Here's the thing, though. The question wasn't about any of these. If the question was, could the mean be 101, we would say yes, of course, because it's in the interval. The question is, can you say that the mean is not 100? And you cannot say that the mean is not 100 if 100 is in the interval, which it is. Okay. Now, the mean could also be 95 or 101 or 105. There's no statistical difference between 100 and those other values because they're all in the same interval. But that's not the question. The question is about 100. Okay, and some students kind of got sidetracked following down these other rabbit holes and arrived at the wrong conclusion. Okay, last thing, because this comes up in the Bear Height case study, and it comes up in homework 9, is comparing two different confidence intervals. Now, I want to preface this by saying that we are treading into dangerous territory, and if we had the time, we would really smooth over the difficult parts of what we are about to do, because there's a number of difficult parts. We don't have that time, so we're just going to kind of smooth this over. But what I'm about to do comes with a bunch of caveats that actually you do learn how to mitigate, but we just don't have time for that. So you'll have to learn it from another teacher. So let's suppose that we have two populations, and we are looking at the average, let's say, height of those populations. So our first sample from the first population gives us a height of, let's say, a mean height that's somewhere between 65 inches and 70 inches. Okay, and that's one of my populations. Okay, now there are two scenarios here. Either this other sample that I take from this other population indicates to me that the means of these two populations are different, or this second sample that I take from the second population does not indicate that I can say that the means of these two populations are different. So what do each of those look like? Let's suppose that the second population, the second sample that I take from that population, I guess the first sample that I take from this population, the second sample overall, gives me a confidence interval for the mean of this population that's 72 to 75. Okay, these two intervals share no values in common. Therefore, there is not any one value that you could say is reasonable as a mean for these two populations. Therefore, you can say that the means of these populations are different because they don't share the intervals don't share any values in common. Okay, and that's what this conclusion would come out of this situation where you have two intervals from two populations of the same thing, of the same attribute, be it height or age or whatever. And because the intervals don't share any values, you can say that the means for these populations are different. Okay. Now the other scenario is that the intervals do share value. So let's say the second population, the interval goes from 69 to 72. Okay. Now there's a narrow band from 69 to 70 of numbers that would be reasonable values for the means of both of these populations. 69.5, for example, and I just chose that because it was in the middle, is a reasonable value for the means of both of these populations. Because these two intervals share values, you cannot say that the means are different. Okay. Now, I also can't say that the means are the same. That's actually a different statement. But I can't say that they are different. I can't detect a difference in the means of these two populations because their intervals share values. There are reasonable values for the mean that work in both. Okay. It is now 11:41, and I kind of need to stop talking and go to bed, really. So I'm gonna stop here, and yeah, talk to you guys later, or not. This might be the last thing that I say in a video. It won't be, I promise.